Artificial neural networks, ANNs, have indeed revolutionized the field of machine learning and have become a fundamental tool in various domains. ANNs are computational models inspired by the structure and function of biological neural networks found in the human brain. Here are some key ways in which ANNs have revolutionized machine learning. 1. Deep learning. ANNs form the basis of deep learning, a subfield of machine learning that focuses on training models with multiple layers of neurons, known as deep neural networks. Deep learning has achieved remarkable success in various tasks such as image and speech recognition, natural language processing, and computer vision. Deep neural networks can automatically learn hierarchical representations of data, enabling them to capture complex patterns and make accurate predictions. 2. Feature learning. One of the significant advantages of ANNs is their ability to learn features directly from raw data. Traditional machine learning algorithms often require handcrafted feature engineering, where domain experts manually design and select relevant features. In contrast, ANNs can learn meaningful representations and features from raw data, eliminating the need for extensive manual feature engineering. This automated feature learning greatly simplifies the modeling process and can lead to better performance. 3. Nonlinear mapping. ANNs can model highly nonlinear relationships between inputs and outputs. By using activation functions and multiple layers, neural networks can capture complex patterns and mappings that may not be easily represented by traditional linear models. This enables ANNs to handle intricate and nonlinear data, making them suitable for a wide range of applications where complex relationships exist. 4. Scalability and parallel computing. ANNs can be trained on large-scale datasets using parallel computing resources, such as GPUs, graphics processing units, or distributed computing frameworks. This scalability allows for efficient training of deep neural networks on massive datasets, leading to improved model performance and the ability to tackle complex real-world problems. 5. Transfer learning. ANNs trained on large datasets can be used as a starting point for other related tasks through a technique called transfer learning. By leveraging pre-trained neural networks, models can benefit from the knowledge learned from previous tasks, even with limited data availability. Transfer learning has proven to be effective in scenarios where labeled data is scarce or when training from scratch is computationally expensive. 6. Versatility and adaptability. ANNs are highly versatile and can be applied to a wide range of problem domains, including computer vision, natural language processing, speech recognition, recommendation systems, and more. Their flexibility and adaptability make them a powerful tool for solving various complex machine learning problems. It's important to note that while ANNs have achieved remarkable success, they also come with challenges such as the need for large amounts of labeled data, computational resources, and model interpretability. However, their impact on machine learning and the advancements they have brought about are undeniable, making them a key technology driving the current state of the field.